next video, punching shear reinforcement design. This is regarding the reinforcement in punching shear. For this we need to provide the reinforcement. It is not, if it is not resisted by the slab itself. So here is a theory portion. This is from the book. So it is given based on the I have shown the previous video about the punching shear without reinforcement design. Now this is the reinforcement design, and this is the theory portion. Here it is given that where the reinforcement should be put in its place in 0.5d from the loaded surface distance and 1.5 inside the control perimeter. This theory portion I'll show you later in numerical. First, here is our numerical problem. A slab is 200 thick with an average effective this is not 250 mm thick slab of class C 2530 concrete is reinforced by 12 mm high bar at 125 mm center in each direction. The slab is subjected to a dry environment and must be carry the ultimate load of 650 kN, and the area of column is given 300 mm in both sides. Determine the shear reinforcement required for we have given FYK 500 Newton per mm square. So we need to design the slab to carry the load of 650 kN. Okay, for this I need to find the effective I need to find the effective depth of the column, depth of the slab. For this I am going to suppose from the numerical cover of reinforcement XE1 and and nominal cover is 25 mm, and after that we are going to use a 2 bar, means 8 mm bar for the link and 12 mm bar high L bar we are using. So 260 minus 25 normal cover plus 8 for the link and 12 mm for the high L bar. It is effective depth we got is 250 mm. Similar like the previous example, need to calculate our maximum permissible force at the face of loaded area. So we need to calculate maximum shear resistance, and RDM is 0.5 UD 0 FCK 250 FCK 1.5. I need, you can see this this one in my previous video. And then after we need to calculate the control perimeter area to find the where the slab can resist that load or not. Yeah, and U1 is 2 plus A plus B plus 4 pi D, the effective depth, and we get the total control perimeter. And it is the shear force without the reinforcement. So BRD means URDC into 3902 into 250, where BRDC is we can get in table 8.2 to this one bending shear ratio. You know that delta 1 is equal to AST by BD. B is we consider the 1 meter 1000 mm into depth 250 0.0042. It is greater than 0.4. From the table we can get it. We need to calculate delta in jet in both direction, and delta is root under delta 1 into delta 2, so it is same in the both directions. So we have calculate only delta, so it gives the same result. And from table 8.2 we get the VRT 0.56, which you can see in my previous video. And modification factor is for the concrete, which I show in the table previous video. This is all from the previous video. After that I will show from this, in this is the new portion. Okay, and for the result I want to show the result is result BRDC is equal to 442 kN, but we need to calculate the load, carry the load of slab 650 kN, so the rear shear reinforcement is required. So check out, now we are going to calculate the outer perimeter at which the reinforcement is not required. So UOD is equal to BED gamma URD CD. BD is 650 into 10.3. This is the modification factor, and this is the shear reinforcement without shear resistance without reinforcement value 0.49 into 94 into depth 250. 250 this here. and D into D. It is, we have this formula. So formula here, it's in the book. Yeah, C into D, and this is, I'll write D, effective D. We got the UNT. At a distance, this we do not need the reinforcement, so this will occur at a distance xt from the face of loaded area. So we have the loaded area, it will be at xd direction. Then we calculate the value. We have the overall value in here to calculate. Oh, it is the over distance into 2 into b into 2 pi 215 means d. So xd is the distance. So it is distance 215 to x, and x is called 3.36. It is greater than 3 meter. Now we need to go on and reinforcement. It is so that figure so that this should replace not more than 0.5 d from the loaded area and distance 1 point inside the outer control perimeter, at which shear reinforcement is no required. The length of this is given. We have calculated the length to from which it is the distance of loaded area is calculated. If it is less than 3.3, it will lies in 0.3 d and 1.5 phase, but it is greater than 3. So we are going to our reinforcement will lie between 0.5 d from the loaded area and 1.5 inside the outer control perimeter. So in provisional reinforcements, here should be right within the, I have written the same things, greater than 0.5 and less than 1.3. It means 1.860 from the loaded surface is 3.36 from the outer surface from the and it is like from here. Particle link should be provided actually at least two. We need to have the 2 parameter, and that should be at the distance 0.75 d apart, and links should be around within the 2d of the face of the loaded area, not greater than 1.5, increasing to 2d. Yeah, considering that now we have considered for parameters less than 0.73 apart, we consider 3 parameters still. Now we need to look at it is we have shown not greater than 0.5 d, 0.4 d, 1 and less than 1.86 and 1.15 d and 1.9 d. That means if we multiply it with 215, we get 85, 240, 400 from the loaded area. So yes, this is the yes r is the tangent into the tangent spacing of link around the perimeter. Okay, since all perimeter lies within 2d, 2 means 430. Our maximum is 400. So maximum link space is limited to 1.5d. Limited to, we have limit maximum space to 1.5d. Yeah. Perimeter look is link spacing perimeter lines 2d space on load area should not be greater than 1.5, increasing to 2d at the greater distance. Here it is written in the code, and we are going to calculate the minimum for the slab greater than, we have the SW minimum, the total area reinforcement in one perimeter. Yes sir, we have the radial spacing of perimeter of shear reinforcement. Here for UD we have 250 into 0.25 d PRDC CS with the punching shear reinforcement. We have everything value. This is value 0.05 d minimum link area. We have this one value, a minimum a minimum leg area. We have take out the minimum leg area. After that, yeah, we have calculated 0.05 t FCK 25 STS R is the real space of the perimeter is 163 and 323 in the maximum limit space maximum. So we have calculated 27.3, which is 6 mm diameter. 665, but we have taken 8 mm diameter. So minimum leg reinforcement we have satisfied our minimum rank reinforcement. This portion we have satisfied. Now we need to calculate the SW area of steel requirement. So area of steel required is equals to ST CS 75 RDC BRDC 1.5 1.5 FYWD EF SSR U1. That's it is all given here. And which means BRDC is the would be BD U1 into D1. So BD U1 into D1 600. BD means we need to resist 650 into 10 to the power 3. U1 is 3902. It's given, and diameter is 215. Is given 0.775. And BRDC it is given in previous at the top from table 8.2. We have calculated it in the top. I will show you. This is the this is the value BRDC 0.56 and 0.94. Then we are going to calculate FYEDEF, that means 250 plus 0.25 into D. It is given that 303. It should be less than FYD. F means designed L strength of steel. So it's 500 by partial factory safety. We divide by 1.5, 235. After that we have tensile space. We have considered the radial tensile space of 160 mm apart. Yes, TW is equal to 0.75. We have calculated everything, and we have required 520 mm area. So number of link. The area of one link is 8 mm, this means 50.3 mm square, and hence number of link required is 523 divided by 3 11 on the outer face. Similarly we have in purpose here. We have used 8 mm diameter, and we have purpose the link spacing at 125 something here. And this one I'll show you. We have distance 85. We have know the distance from load face is 85, 245, 400, and length of parameter will be like this. It is calculated that 2a plus b into, it is written like here 4 pi d, but not, is 2 pi d, 2 pi r, and by this way we calculate our length of perimeter. And so it's 2 into 300 plus 2 into 3.16 into d, 85 is equals to, it is 1734. We have given round figure, and regular link spacing is 734 divided by, we need the 11 bar, that means 11 bar. So that means we have considered space 158 required space, and 230 divided by 11, 240 and 730, and purpose spacing we have keep 125, 250, 200, 250. We assume it should be within the limit of 323. So we purpose the number of link. It is given by 734 divided by 125. We get the number of link is 14, and for is 11. Minimum link we required is 11. That's fine. It satisfies the condition. And 15. By this way we calculate our reinforcement for the punchings here. Thanks for watching.